So let's begin by looking at what we should know how to do at this point in our linear algebra career. So this is just do a quick episode recap. What we want to be able to do at this point is to start with a linear system, write down an augmented matrix of the linear system, find the reduced row echelon form of that augmented matrix, and then use the reduced row echelon form to write the general solution. So that's what the process that we have so far. Start with a linear system, convert it to an augmented matrix, take the augmented matrix to the reduced row echelon form by performing row operations, and then you use the reduced row echelon form to write the general solution to the linear system. So in the middle, the two in the middle are both matrix things. We're performing row operations on the matrix. The reduced row echelon form is of the matrix. The general solution goes with the linear system. So we want to be careful that we use the right words with the right things. We don't want to talk about the solution to the matrix. That doesn't make any sense. And we don't want to talk about the pivots in the general solution, because those two also do not go together. So right now what we need to be able to do is take a linear system, say x1 minus x2 is equal to 1, and 3x1 plus 2x2 is equal to 8. Write down the augmented matrix of the linear system, which in this case would be by columns 1, 3, negative 1, 2, 1, 8. Find the reduced row echelon form of the augmented matrix, which in this case will be 1, 0, 0, 1, and then I think it was 2, 1, and use the reduced row echelon form to get the general solution. So this would tell us that x1 is equal to 2 and x2 is equal to 1. And then we could check, see 2 minus 1 is equal to 1, 3 times 2 is 6, plus 2 times 1 is equal to 8. So we convert to the linear system to the augmented matrix. We perform row operations on the augmented matrix to get to the reduced row echelon form, and we use the reduced row echelon form to get up to the general solution. Any questions? Here's one of the things that we may have noticed. So another one of our systems said x1 minus x2 is equal to 1. And then the other equation said, I have it here. The other equation was minus x1 plus x2 is equal to 1. So converting this linear system to an augmented matrix, we would get by columns 1, negative 1, negative 1, 1, and then 1, 1. The reduced row echelon form of this system, will be by columns 1, 0, because if we just add the first row to the second row, 1 minus 1 is 0, negative 1 and 1 is 0, and then 1 and 1 is 2. So what we see when we can find the reduced row echelon form of this linear system, since there is a pivot in the rightmost column of the augmented matrix, that tells us that there are no solutions. So we don't really write down the general solution form. In this case, we have a pivot in the rightmost column of the augmented matrix, and that tells us that there are no solutions to this system. These two equations represent parallel lines. So in this case, In the previous case, we had a pivot in the first row, first column, and the second row, second column. But in the second example, we had a pivot in the first row, first column, and then the next pivot was in the second row, third column. So if there's a pivot in the rightmost column of the augmented matrix, that tells us that there are no solutions. So we have a pivot in the rightmost column of the augmented matrix. And that tells us that there are no solutions. And the solutions are a thing that belong to the system. So there are no solutions to the system. So a pivot in the rightmost column of the augmented matrix indicates that there are no solutions to the system. If we look at what this last equation says, the last equation says 0x1 plus 0x2 is equal to 2, and that does not have any solutions. So this last equation says 0x1 plus 0x2 is equal to 2. And that means that 0 is equal to 2, and that is a contradiction. If we divide this last row by 2, well, we'll have a 1 there. We usually, for the reduced row echelon form, all the pivots have to be 1s. But if we just want to find out where the pivots are, we don't have to get them all the way down to 1s. So this, you are correct, though. This is not quite reduced. So this one is not quite reduced. But if I just divide that by 2, that'll turn it into a 1. Any questions? There was a third example, which I won't fit. Let's go on to the third example from problem 4, which had x1 minus x2 equals 1. And then the next equation was just minus 1 times this equation. Minus x1 plus x2 is equal to minus 1. So we write down the augmented matrix of this linear system. By columns, that would be 1, negative 1, negative 1, 1, and then 1, negative 1. Now if I add the first row to the second row, my first row will stay the same at 1, negative 1, 1, and my second row zeroes out. So we only end up with a pivot in the first row, first column. But we did the same thing, took the linear system to the augmented matrix, to the reduced row echelon form, and then we can use this to write the general solution. If I make a note that this first column corresponds to x1 and the second column corresponds to x2 and the third column corresponds to constants, I use a k, the mortal constant, then I can solve for the basic variables in terms of the free variables. So x1 is basic and x2 is free. So in this case, x1 is equal to 1 plus x2, and x2 is free. And there's the general solution. Remember that it's not sufficient to just say there are infinitely many solutions. Our task is going to be to recognize that there are infinitely many solutions and then describe those infinitely many solutions. So here we have a solution for every value of x2, the free variable. Any questions? Comments? Snide remarks? Great. Let's pause the recording right here.